Hello students, welcome to the class. We will continue our discussion of geometrical optics. So in the last class we have seen the ray diagram. Now here we will see the mirror formula. So after ray diagram we will see the mirror formula. Mirror formula is basically the relation between image distance, object distance and focal length. This is representing image distance. This is representing object distance. And this is representing focal length. In mirror, you should understand that all the distances are measured from the pole of mirror. Measured from the pole of mirror. One thing I would like to clarify you, pole is not a fixed point. Suppose this is the mirror that I have taken and here you see, here is in the middle point, we call it as pole. So this is pole, this is the convenient place point from where the object distance and image distance are measured. In this way, then here is the pole. This is the end point, you see. So pole can be treated as any point which joins the center of curvature and the surface of the mirror. So that can be the pole. So it is not as a, for convenience we take this midpoint of the middle of the mirror as the pole. This thing you all should remember. So this is the object distance, image distance and focal length. Now the relation exists is 1 by V plus 1 by U is equals to 1 by F is equals to 2 by R. This is basically the relation between object distance, image distance and focal length, and this is called your mirror formula. Now we will try to understand how we can derive the mirror formula keeping the ray diagram in mind. So in the mirror formula, I am taking a concave mirror and X, P, Y, this is pole. Here is the point object I am taking O. This is the incident ray. Here is the focus. Here is the center of curvature. The mirror formula that we will be taking is valid for the paraxial rays only, and for paraxial rays, if we join this ray, then this will be normal and this is angle of incidence. So this is the ray that is going, one ray passing through center of curvature, it will retrace, and here is the image that is being formed. Keeping the point object in mind, so object is there and image is real. You know that when object is beyond center of curvature, the image is formed between center of curvature and focus, that we have understood in the ray diagram. So this angle is also theta. This point I am taking as M. If I consider this point as M, here you should understand that I am dropping a perpendicular and this is N. So in this situation, this distance, whatever distance we are measuring from the pole, this distance is your U, this distance is your R, this distance is your V image distance, and this distance is your F. Point object we have considered. We can do it for extended object also. Now, if I consider this angle as alpha, this angle as beta, and this angle as gamma. So, what we can do in the triangle OCM, triangle OCM, can you see beta is equals to alpha plus theta, exterior angle, exterior theorem. So, beta is equals to alpha plus theta. In triangle CMI, gamma is equals to beta plus theta. Take it as equation number 2. So, if we subtract 2 from 1, 2 minus 1 gives gamma minus beta is equals to beta minus alpha, or gamma plus alpha is equals to 2 beta. This also we can write. Now, when the angle theta is very small, then we can consider that alpha, beta and gamma are small. So, for mirror of a small aperture, alpha is equals to tan alpha, that is equals to perpendicular by base, perpendicular MC by base is your ON. Beta, tan beta, that is perpendicular MN. Perpendicular is not MC, perpendicular is MN. MN by base is your CN, and beta is equals to beta, and gamma is equals to tan gamma is equals to alpha is equals to, and gamma is tan gamma is equals to MC MN by IN. So, what we are getting? We are getting gamma plus alpha, that is MN by IN, gamma plus alpha plus MN by ON is equals to 2 beta 2 MN by 2 beta 2 MN by CN. This MN will cancel. Now you see, when this angle is very small, that is mirror is of a small aperture, for clarifying I have made a big diagram, but this M point is very near to P. So, M point is very near to P, so IN is equals to IP, as point N is very near to P. Therefore, ON is equals to OP is equals to U, CN is equals to Cp is equals to R, and In is equals to Ip is equals to V. When we keep this thing in mind, putting this value, what we are getting, In 1 by V plus On 1 by U, 2 by Cn, 2 by R, that is 1 by F. Therefore, 1 by V plus 1 by U is equals to 1 by F. This is your mirror formula that I have proved using the point object concept. You can prove this formula with the help of extended object also, that is given in the book. In most of the book it is given in this way. Now whenever you are applying, now this mirror formula is valid for both concave and convex mirror, but U, V and F are to be kept with sign. What does it mean by sign? That I will discuss right now with the sign convention. So this is the simple proof of your mirror formula, and I have kept that the object is point object on the principal axis. Now we will try to understand the sign convention. Sign. In sign convention, don't confuse with the sign convention that is given in some books. Some books Cartesian sign convention is given and you will get confused, but we have to follow the sign convention according to our NEB syllabus, Nepal board syllabus, that the sign convention, whatever is real, that has to be taken as positive. If you go in engineering side, again you will find the same Cartesian sign convention, but for our syllabus in +2 level we have to follow this sign convention only, and whatever is virtual, that can be treated as negative. So focal length of concave mirror, we have to consider positive, and in Cartesian sign convention this is negative, so don't get confused. In Cartesian sign convention this is treated as negative. And focal length of convex mirror, that is treated as negative because this is virtual. So this is the sign convention. And one more thing, all distances are measured from the pole of mirror. These are the basic things that we will keep in our mind, and then we will apply the mirror formula. Now in mirror formula, now we will verify the ray diagram that we have discussed. Suppose in a mirror, concave mirror, focal length is 20 centimeter and object distance U is your 60 centimeter. You have to find the position of image. Now you can guess, by this question you can guess that object position is, this is focus, this is center of curvature, so it is 20, it is 40, so object position is somewhere here, beyond center of curvature. So we should get the position of image somewhere here. This is the object, so we should get. That means the answer should come between 20 and 40. Let us check. So 1 by V plus 1 by U is equals to 1 by F. So 1 by V, don't put the value in the initial stage. Just in final stage you will get the value, you will put the value and you will get the result. So 1 by V is equals to 1 by F minus 1 by U, that is U minus F by UF. So V is equals to UF by U minus F. This is the value of V you are getting, and if you are getting the value of U, V, then put the value of U. U, real object is there, so 60 into F, that is 20, by U minus F. U is 60 minus 20, 60 minus 20, and this is giving you 60 into 20 by 40, 0, 0 will cancel. Now you see, this 30 centimeter is between F and 2F. So this is verified. So when the object is beyond the center of curvature, we have verified this by an example 1. Now in the second case, the object is at center of curvature, we have discussed. So if the object is at center of curvature, image is also formed at center of curvature. Check. Let us check. Second case I am taking U to be 40 centimeter and F keep the same 20 centimeter. So V is equals to UF by U minus F, that is 40 into 20 by 40 minus 20, that is 40 into 20 by 20, 20 will cancel and 40 centimeter is the result. This is also verified that when the object is at center of curvature, the image is also center of curvature because F is this and R is 2F, that is 40 centimeter focal length is. So second condition is also verified. Now let us take the third condition, that here in this case the object is between C and F. So if the object is between C and F, this position we have got the image, to be 30 centimeter. Let us suppose that this is the object, this is the position of object. So for third situation U is equals to 30 centimeter, F remains the same 20 centimeter. So V is equals to U into F by U minus F, that is 30 into 20 by 30 minus 20, that is 30 into 20 by 10, this will cancel, that is 60 centimeter. Now you see, one very important result is coming. A very important information is waiting for you. What is that? If U is 60, V is 30, and if U is 30, V is 60. That means this U and V can be interchanged. At the place of 30, if U is 30, V is 60. If suppose u is x and v is y, then it means if u is y, then v is x. This is the thing that I want to make you understand. So this thing should be clearly, this object and image distance should be replaced, can be replaced, that this can be substituted by this. So these are interchangeable. For 30 centimeter image distance, object distance is 60 centimeter, and for 60 centimeter object distance, image distance is 30 centimeter. This thing should be clearly understood into the mind. Next thing is there, at focus it will be coming infinity. Next thing is there between focus and pole. So between focus and pole, a distance I am considering, this is suppose your, this is your 20 centimeter, so I am supposing this distance, suppose 10 centimeter. So next case is the fourth example I shall be taking. Fourth example I am taking, if suppose u is equals to 10 centimeter, suppose u is equals to 10 centimeter and f is same, that is your 20 centimeter. So v is equals to uf by u minus f. What does it mean? 10 into 20 by 10 minus 20. That means what you are getting? 10 into 20 by minus 10. This will cancel. Minus 20 is your answer. V is equals to minus 20. What does it mean? Minus sign represents about virtual image. Minus sign represents about virtual image. That means image is in this side at a distance 20 centimeter from the pole of mirror. So this thing, by giving this much example, you can understand, and this concept, those who has kept the ray diagram in their mind, they can verify this way, and this way you are able to solve many simple questions in a very comfortable way. You can solve these questions with confidence and chances of doing mistake will be very less. One more thing, if I suppose this is our object, virtual object is there. If I suppose this is our virtual object, if this is our virtual object, next case I am taking, next case, suppose fifth case I am taking, that u is equals to, how much we have calculated? Minus 20. U is equals to minus 20 centimeter. What does it mean? It means virtual object. Virtual object. Virtual object is there. And f is same, that is 20 centimeter. Then value of v will be what? V is equals to uf by u minus f. So u is your minus 20 into 20 by u. U is how much? Minus 20 minus 20 minus 20. So you are getting minus 20 into 20 by minus 40. 0 0 will cancel, 2 2s are 4, minus minus will cancel, 10. That means at the distance, and you are getting plus 10. What does it mean? Real image. Real image is formed. Real image is formed at 10. That means if the object virtual object position is this, then real image position will be somewhere here on the principal axis, that is at the distance of 10 centimeter. So this thing has to be clearly understood by you people. Now we will see the case of convex mirror. Now it is the case of convex mirror. Convex mirror. In convex mirror, what we have observed? We have said that focal length should be negative. Suppose f is equals to 20 centimeter. So it is negative, so we will take minus. U is equals to, suppose, 60 centimeter. If U is equals to 60 centimeter, find the position of image. So again, object is real. What does it mean? It means that real object. Real object. So when the object is real, 1 by V plus 1 by U, 1 by F. So 1 by V, 1 by F minus 1 by U. So U minus F by UF. So V is equals to UF by U minus F. And you are getting 60 into minus 20 by 60 minus minus 20. So that is 60 into 20 minus sign with 60 plus 20, that is 80. This will cancel. Now you see, one thing is important, that in convex mirror, whatever be the position of object from pole to infinity, the image is always formed between focus to pole. Always the image is formed in between. Here negative sign means what? Virtual image. So image is virtual in nature, and this is the convex mirror. Focal length is 20 centimeter, and here this is 20, and image is formed somewhere here. This is the position of image. So what we have seen? We have seen that this is the virtual image. Now let us take the example of virtual object. Suppose if U is minus 60, that means now it is virtual object. If it is virtual object, then V is equals to how much? V is equals to, you will get minus 60 into minus 20 by minus 60 minus minus 20. So you are getting 60 into 20 by minus 60 minus 40. So it will cancel. 2 to the 4 minus 30 centimeter. Here you see, provided the calculation is correct. Here you see, virtual object is there and virtual image you are getting. So virtual image of virtual object is formed by convex mirror. This is also possible that the virtual object forms the virtual image in case of convex mirror. This thing you all should keep in mind, and then we will move towards the magnification side. Now the general confusion comes about the virtual object. What is a virtual object? Virtual object is basically a concept that rays are converging. Suppose that I am taking a concave mirror. And ray of light is going in this way. Here is the center of curvature, so that this angle should be equal. This angle should be equal to this angle should be equal to this. So final image is formed here. If before the final image, if some system, the reflected ray are meeting here, if some system is kept here, suppose another concave mirror is kept here, then you will observe that for this concave mirror, this initial image will behave as the object for this mirror M1, M2. For this mirror, it will behave as a, here, this is the incident ray. This is the incident ray. What does it mean? This is converging incident ray. Before they are making the image, we have kept a object. We have kept a mirror. So this will behave as a virtual object. You can understand it in a better way. I have not discussed lens, but some basic primary knowledge of lens I would like to tell you, that here is the object and here is the image that is being formed. If before the image, if I keep a object, concave, convex or whatever mirror I am keeping here, this is a mirror I am keeping here, then this will behave as a virtual object for this mirror, whether it is concave, whether it is convex, whatever mirror is there. So always keep in mind that virtual object concept is basically this, that means rays should be converging. If a concave mirror is there and we are taking this type of ray, then this is a virtual object for this mirror. This is a virtual object for this mirror. This distance will behave as the virtual object distance. Or you can take the convex mirror also, that if I am taking a convex mirror, this is the virtual object for your convex mirror. X1, P, Y, X2, P, Y. Rays should be converging. These rays are converging in nature. So basically they represent virtual object. So this is the thing that you should keep in mind. One more thing that I have not discussed about the aperture. Sometimes the question can be framed on aperture also. Suppose from this sphere we have cut one portion, this is your R, this is your small r. So this R represents your aperture. R radius it is radius of aperture. And what is R? This is radius of curvature. So this thing should also be, and this your center, this thing should also be kept in your mind. Large curvature, large radius of aperture means big size mirror. A small radius of aperture means large size, a small radius of aperture means a small size mirror. So radius of aperture, R tells about the size of mirror. What about the curvature? If radius is large, curvature is small. If radius is small, the curvature is large. R large means curvature small. R small means curvature large. One more thing you should keep in mind, that for plane mirror, curvature is 0. Curvature is 0. So radius of curvature is infinity. So radius of curvature is infinity. This thing will be also helpful in understanding the spherical mirror in the better way. Now we will talk about the magnification. Magnification. Magnification is basically about the image, that whether the image is bigger than the object, smaller than the object, or same size the object. If magnification is positive, it means real image. If magnification is negative, it means virtual image. If magnitude of magnification is greater than 1, it means magnified. If magnitude of magnification is less than 1, it means diminished. That means smaller in size. With respect to object. And if magnitude of magnification is 1, that means same size. Size of object and image is same. Now next thing is there to understand that magnification is defined basically. Suppose I am taking a concave mirror. Here is the object. Here is the image. Object is there, AB, and A dash B dash is the B dash is the image. This angle is theta, then this angle is also theta. This is V and this is U. Height of object, height of image. So theta is small. Here you observe that theta is small. So tan theta is equals to HO by U is equals to HI by V. So HI by HO is equals to V by U. This formula gives you the magnification. This is called M, that is magnification. For convex mirror it will be negative. Why? V is negative. So this formula is also helpful in finding the height of image, height of object, object distance and image distance. So this tells about the magnification. Now magnification, some other formula are also very important for your magnification. What is that? 1 by V plus 1 by U is equals to 1 by F. If I multiply this relation by V, what we are getting? 1 plus V by U is equals to V by F, and V by U is called magnification. So V minus V by F minus 1, that is V minus F by F. This is also the formula of magnification. Similarly, we can also design the formula. If I multiply this equation by U, then U by V plus 1 is equals to U by F. This will be 1 by magnification. So 1 by magnification, U minus F by F. So M is equals to F by U minus F. This can also be treated as the formula for magnification. So this, and this, all the value gives you the magnification. Wherever necessary, use them with sign. You have to use them with sign, and meaning decoding can be done with this relation. This table will help you in understanding the meaning of the magnification, that when it is magnified, when it is diminished, and all these things. So let us do one question based on magnification. Suppose that the magnification of a concave mirror is given 2. That means it gives double the size of image, and you have to find focal length, suppose 20 centimeter, and you have to find the position of object. Focal length is, now in this situation, if the magnification double the size of object, double the size of object, this is given. 2 is not given, because you will understand plus 2. It means that it is plus minus 2. Why plus minus 2? Because in concave mirror gives you magnified image in 2 cases. Remember the ray diagram. One case, between focus and pole, if the object is there, you get a magnified image, and between the focus and center of curvature, the object is there, then you get a magnified image. So what is important to understand in this? It is virtual and magnified, for which I will consider minus 2, and it is real and magnified, for which I will consider M is equals to plus 2. So using M is equals to V minus F by F, 1 by V plus 1 by U is equals to 1 by F. So multiply by V, 1 plus V by U is equals to V by F. This is M V minus F by F. Put the value plus 2 V minus 20 by 20. So we are getting 40, there was V minus 20, so V is equals to 60 centimeter. In concave mirror, if the object is, in concave mirror focal length is 20 centimeter, then image position will be, what we have to find? We have to find U and we are finding V. Then how the answer will come? U is equals to M is equals to F by U minus F. So plus 2 is equals to F means 20 by U means U minus 20. That means 2u minus 40 is equals to 20. So 2u is equals to 60. So u is equals to 60 by 2, that is 30 centimeter. This is the value we are getting. By this you can find the v, 30 and v. And if we are taking m is equals to minus 2, if we are taking m is equals to minus 2 f by u minus f, minus 2 is equals to 20 by u minus 20. So minus 2u minus plus 40 is equals to 20. So minus 2u is equals to minus 20, u is equals to 10 centimeter. So one answer is this and one answer is this. And corresponding value of v also we can find. As we have find the object distance, in the same way we can find the image distance also. So u, when the object is at a distance of 10 centimeter, this is 20 centimeter. We are getting the virtual magnified image, and if the object is at a distance of 30 centimeter, we are getting the real magnified image. This is the way we can use the magnification formula and we can easily find the position. This question can be also framed that find the image position. As we have calculated the object position, in the same way we can find the image position also. So hope with this much discussion of magnification and mirror formula, some clarity of concept might have taken place, and it will make you capable in solving many unsolved problems by yourself. Practice more, work hard and improve yourself as far as possible. Thank you.